Hello, pre-algebra students. Today we're going to be looking at the guided notes called How Do We Get the Variable from Both Sides to Just One Side? And so what this is going to be all about is going to be algebraic equations where the variable is on both sides of the equation, both sides of the equal sign. And so that makes these problems very interesting. I'm going to tell you right now, our goal for today is just to learn how to get the variable to be on just one side of the equation. So how do I do that? Well, the answer is in the box. The way that you get the variable on one side is to add the opposite of one of those variable terms, but to do it to both sides. And so obviously there's two different variable terms. When I say variable terms, I mean the terms with a variable. So in this case, it'd be 8y or 2y. And so what we're going to do is, as it says here, follow along, we're going to add the opposite of one of the variable terms. And when I say the opposite, I mean if it was positive, then the opposite would be negative. If it's negative, well, then the opposite would be a positive. And I'm going to show you why that's going to work. Follow along with me. And so we have two choices here. We can either add the opposite of 8y, or we could add the opposite of 2y. Either one, we get to choose. As long as we do it to both sides, then we're allowed to do it algebraically. So let's take a look at this. Here's option one. We could add by the opposite of 8y, which of course would be negative 8y. Now notice how I lined it up. Like terms do matter whenever you add or subtract. So this is why I had to put the negative 8y underneath the positive 8y from the original equation, and also underneath the 2y. It would make no sense to put it underneath the 17 or the 38 because they do not have the variable y, and therefore they would not be like terms, and that would just create all sorts of problems. You can only add or subtract when things are like terms. Now, why does it help to add the opposite of 8y? Off to the side, I show you exactly what happens. 8y plus negative 8y gives you 0y. But what does 0y actually mean? It means 0 times y. Well, what is 0 times y? 0 times anything is 0. And so what happens is that on the left side, where we had 8y plus negative 8y, we get 0. It's 0y, which really just means 0 times y, which is 0. And then, of course, 0 plus 17, we all know that is just 17. And look, boom, the variable is now no longer on that left-hand side because we got 0 times the variable, which is just 0. Now, obviously, the variable is still on the right-hand side. 2y plus negative 2y would give you negative 6y. And so there you go. The variable is on the right-hand side. So that's the first option for what you could have done here. You could have added the opposite of 8y, which would be negative 8y. The other way of doing this would be to add the opposite of the 2y. The opposite of 2y would be negative 2y. And so we're going to add that on both sides. Once again, you have to line up the terms properly. Whenever you add or subtract, got to have like terms. So notice it's underneath the terms that have variables. Do not put it underneath the constants, the numbers with no variables. Got to line it up properly. Okay, so where was I? 2y plus negative 2y. Why is this helpful? Because 2y plus negative 2y would give you 0y. And this is very much like I showed you on the last time. 0y means 0 times y, which is just the same as 0. So boom, that is how we no longer have a variable on the right-hand side. And then 38 plus 0 is just 38. And then the variable now remains only on the left side. 8y plus negative 2y is 6y. Now, if 6y sounds familiar to you, it's because the other version had a negative 6y, but on the right. And so that is kind of interesting, isn't it? But here's the bottom line. Either way you do it, option 1 or option 2, At that point in time, you will now have the variable on just one side of the equation. And then, if we were going to finish solving for the y, then we would answer the question of what's happening to the variable. Of course, there would be two things, wouldn't there? Being multiplied by -6, added by 38, or in the other case, multiplied by +6, added by 17. But anyway, we would ask what's happening to the variable, and then we would do inverse operations on both sides to get the variable by itself. We're not going to do that today. And I'm sorry if that disappoints you. We will do that tomorrow, but not today. Today, our only focus is to get the variable to go from both sides to just one side of the equation. That's our goal today. All right, here is another problem. We have 5 minus 6w equals negative 19w plus 70. Now, my experience when kids start doing this for the first time is that it's helpful for them whenever they have subtraction to make it adding the opposite. At a certain point, you might not need to do that when you become more experienced with this. And I would bet if your parents are good at math and they still remember how to do this, they probably wouldn't make subtraction adding the opposite. I bet students in Algebra 1 or Algebra 2 or other higher levels of math probably don't make subtraction adding the opposite anymore. But at the pre-algebra level, I think for your beginning experience with variables on both sides, I think it's going to be helpful for you to make the subtraction become adding the opposite. All right, and here's why this is important. You need to know what you're going to add on both sides. You could add by 6w. Now notice, positive 6w. Why? Because it's the opposite of negative 6w. Why is this helpful? Because negative 6w plus positive 6w would give you 0w, which means 0 times w, which would just be 0. Would you have known to add by positive 6w with the way it originally was as subtraction? If so, great. Then maybe you don't need to make subtraction adding the opposite. I don't know. But maybe others of you would not have realized that. Maybe others of you would have accidentally thought this was a positive 6w, and therefore maybe you would have accidentally added by negative 6w to both sides instead of positive 6w to both sides. So this is why I think for most of you, it's going to be helpful, at least for now, to make subtraction adding the opposite on the original equation. Then you'll know what to add by on both sides to get your 0. Negative 6 plus positive 6 is 0. 0w gives you 0. And then, of course, 5 plus 0 is just 5. Right-hand side, or sorry, not right-hand side. The other way of doing this problem would be to add the opposite of the negative 19w. And so that would be positive 19w, because again, a negative 19 plus a positive 19 would give you 0. Now you would technically get 0w, but as I told you above on number 1, 0 next to a variable means 0 times that variable, which is how you end up just getting 0. And then of course 0 plus 70 is 70. The left-hand side, where you had negative 6w plus 19w, that gives you 13w. Again, I think it was definitely helpful to make the minus 6w plus negative 6w, because I wonder how many of you would have accidentally thought that this 13w would have been a 25w if you kept the minus as minus. Again, this is why I've learned from experience that at the pre-algebra level at least, it helps kids, at least at the beginning when they're first doing these kind of problems, to make the subtraction adding the opposite, so that way they know it's a negative 6w plus 19w, which is 13w. And finally, before we move on to number 3, I cannot emphasize enough how important it is that you line up the addition that you're doing under the correct terms. You have to have like terms in order to add or subtract. So the terms with w's go underneath the other term with w's. It does not go underneath the 5 or underneath the 70 because they did not have w's. Please line it up correctly, otherwise it's going to mess you all up and you might accidentally add unlike terms, which is just a huge no-no. Okay, Problem number 3. This one is not done for you. Let's talk about this. This is a little interesting because notice the left side only has 18m. That's it. There's not like 18m plus something else. It's just 18m. Since that's the side that only has a variable term, then if you want to do these problems smarter, not harder, it's going to be the fastest for you to get the variable on that short side. Let me show you what I'm talking about. Let's get the variable on the left side, and in order to do that, we need to get the variable away from the right side. So let's add the opposite of 11m, which would be to add by negative 11m. 11m plus negative 11m would give you 0m, which is really just 0. And then 0 plus 39 gives you 39. The left side, 18m plus negative 11m, would give you 7m. Now, why did I suggest getting the variable on the left side? Because look at the kind of equation that you have remaining. It's the kind of equation that only has one thing next to the variable. And therefore, you would only need one inverse operation to solve. But if you would have got the variable on the right-hand side, then you would have had negative 7m plus 39, and then you would have had two things happening to your variable, which would then require two inverse operations to solve. Now, I know we're not solving today the whole way, but tomorrow we will. So this is why I'm trying to teach you that if you have an equation like number 3, where one of the sides of the equal sign is very short and only has a variable term, that's the side that I suggest that you get your variable to end up on, because that will be the quickest way to then solve the problem if we were solving the whole way. Okay, let's do a few more together. Problem number 4. Now, the reason I wanted to do number 4 with you is because you'll notice we have a variable term where we do not see a coefficient on the variable. When I say a coefficient, I mean a number times the variable. Like here it's 10 times x, but on the other x we don't see a coefficient. What is the coefficient? Don't we need to know if we're going to end up adding the opposite of that variable term? Yeah. So here's what you need to know. Multiplicative identity property in reverse. 1 times anything is itself. So 1 times x is the same as x. And understanding that, then you will understand why you could add by negative 1x, and then 10x plus negative 1x would give you 9x. When I've seen kids who try to say add by negative x, I see a lot of kids who don't know how to do 10x plus negative x. And so this is why I think it was worth my time to review this with you, that x is the same as 1x, and that's helpful when you have to add negative x to both sides, in this case negative 1x. That's how you're going to get 9x. And then you're going to have plus 82 equals 0 plus 31. Do we really have to show the 0 step anymore? I'm going to vote no. I really don't think that. I bet a lot of you are ready to stop showing the 0 step on number 3, let's be honest. So you don't want to show that 0 step anymore, fine with me. Fine with me, as long as you understand what's mathematically going on here. That 1x plus negative 1x would give you 0x, which means 0 times x, which is just 0, and that's how you end up with just the 31. Now, the other way of doing number 4, you could have added by negative 10x to both sides, which would then give you 82 equals negative 9x plus 31. Do I care which way you do it? No, I do not. I totally don't care. Your choice. But I can't predict which way you're going to do it, which is why, and this is the only reason why, that I'm actually showing each problem twice here on my screen. So that way when I go over it, I'll have both methods covered, and that way any kid sitting at home will be able to check their work no matter which way that they did it. Okay, so what do we have remaining? Numbers 5, 6, 7, 8, and 9. Wonderful. I want you to try those problems on your own. Again, the goal is to get the variable from both sides to end up on just one side, and the way that we do that is we add the opposite of one of the variable terms. You get to pick which variable term you want to add the opposite of, your choice, but that's what we're going to do. So hit pause on the video. Do 5, 6, 7, 8, and 9 on your own, then hit play when you're ready to see how you did. Okay, I hope you already did 5, 6, 7, 8, and 9 on your own. If not, please, please, please hit pause now, because at this moment I am now going to go over them. Problem number 5. I recommend adding by the opposite of negative 15h, which is 15h. And the reason why I recommend to do that is because then you end up with 37h equals 63. And that's a nice short equation to then solve if we were going to solve the whole way today, which I know we're not, but that's a nice short simple equation to solve. If you did it the other way, adding by negative 22h, that would give you 0 on the right side of the equal sign, and you cannot make that 0 disappear. Do you know why you can't make that 0 disappear? Because you got to have something on the left side and on the right side of an equal sign. You can't just have a blank space on a side of an equal sign. So this is why I don't recommend doing number 5 this way. Because think about this. Wouldn't it be quicker to solve 37h equals 63 than to solve negative 37h plus 63 equals 0? Yeah. The way I have highlighted in yellow is the quicker way. So, moral of the story, whenever you have an equation where one of the sides is only the variable term, that's the side you should get the variable to end up on. That's the side, because that will give you a much quicker equation to solve in the end. All right, having said that, either way is technically acceptable. All right, number 6. My recommendation is to make subtraction become adding the opposite. And I want to show you why I would do that. Now, you could add by negative 9c or you could add by negative 33c to both sides. The choice is yours. But do you understand what you're going to get when you do that? You see why I would tell you to make subtraction adding the opposite? Because if you don't, are you going to realize that this minus to the left of the 45 makes it negative 45? I don't know if all of you would have. So maybe you should make it adding the opposite. So that way you know it's going to be negative 45. Now, is it helpful to make it adding the opposite on the minus 10? Maybe not. Because you could keep it minus 10. You could make it plus negative 10. They mean the same thing, either way. So maybe that place is not as helpful to make it adding the opposite. Your choice. By the way, 33c plus negative 9c is 26c. Now, on the other one, to add by negative 33c, which would give you 0 on the right side, that minus 10 is the same as plus negative 10. That's why you end up with negative 10 on the right side. Do you have to make subtraction adding the opposite here on the left side? Maybe not. I mean, if you want to make it plus negative 45, you could. Or you could keep it minus 45. I mean, they mean the same thing. Either way is fine. This is why I keep going back and forth here. Either way is fine. But you got to have a negative 10 on the right if you did it that way. Or a negative 45 on the left if you did it that way. Choice is yours. All right, number 7. Notice that this problem had the variable short on the right, or the variable term only on the right side. So I think it's best to then get the variable on that right side. So you would get negative 71 equals negative 6n. Now, if you do it the other way, which I would not advise, you would add by negative 2n on both sides. And so that would give you 6n minus 71 equals 0. Now, if you made subtraction become adding the opposite, then you would have plus negative 71n. Same thing as minus 71. On that situation, maybe it's not as helpful to make subtraction adding the opposite. Your choice. Your choice. Again, I think the version over here on the left is the better one. because if you were going to solve the whole way, that would definitely be shorter. Okay, number 8. Did you realize that k is the same as 1k? And therefore, you could add by positive 10k to both sides, which would give you 11k plus 25 equals 3. Or you could add by negative 1k on both sides, which would give you 25 equals negative 11k plus 3. Either way is acceptable. Problem number 9. Maybe you made subtraction adding the opposite. Maybe. You could add by 15x on both sides, which would give you, did you realize that would give you 11x? Because that minus 4x is like plus negative 4x, and negative 4x plus 15x is 11x. So again, maybe in that situation it is helpful to make the subtraction add in the opposite. Otherwise, you might have been fooled into thinking it was going to be 19x, which it's not. The other way of doing it, you could add by positive 4x on both sides, and that would give you 16 equals negative 11x plus 20. I apologize for the random vertical line over there. That was a typo. You can ignore that. But there you go. There's how you could do those problems. All right, there is a practice worksheet that I passed out to you, or that I gave access to you, either in Canvas or I handed it to you in person, either way. I would like for you to try these problems on your own. I'm not going to speak a lot about them when I go over them. I'm just going to kind of show each part of the screen for about 5 seconds and then move on to the next screen. The reason I'm starting here on number 5 is because numbers 1, 2, 3 are already done for you. And you should recognize them. I believe, 1, 2, 3, and 4 were done for you. You should recognize them. They were problems that I actually already had on the guided notes. So hit pause on the video. I don't know, maybe do at least half of the problems. Your choice. Maybe do at least half of them and then check to see how you did. So hit pause now, do at least half of the problems on this worksheet, and then hit play when you're ready to see how you did. Okay, I hope you did maybe at least half of these problems on your own. I am not going to say a lot about them out loud. I'm just going to kind of show you each screen for about 5 seconds or so. If you need to hit pause to check your work, please feel free to do so. Here's 5 and 6. And yes, I'm doing them both ways just to make sure I have both ways covered. Here's 7, 8, and 9. Feel free to hit pause if you need to. Here's 10, 11, and 12. Feel free to hit pause if you need to. Here's 13, 14, and 15. I apologize for my horrible handwriting down here, but these are supposed to be plus negative 1 x's. Hit pause if you need to. And then here's 16, 17, and 18. Again, hit pause if you need to. All right, that concludes this video lesson on how we get the variable to go from both sides to just one side. Thanks for watching. We'll see you next time.